Last time we started with Taylor series and Maclaurin series. Taylor series of the function f at the point A goes like this. F of x can be represented as the summation nth derivative of f at A over n factorial times x minus a to the n power. So if we expand that out, then that becomes f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial x minus a cubed and so on. We also learned about the Maclaurin series. I said Maclaurin series is Taylor series of the function f at 0. So f of x can be represented as power series summation n equals 0 to infinity nth derivative of f at 0 over n factorial times x to the n power. That equals f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial x squared plus and so on. So the problem we were working on were about the Maclaurin series, and we wanted to figure out the radius of convergence together. So find the Maclaurin series for the function f of x and the radius of convergence r. So we did one example. The next example is f of x is natural log of 1 plus 5x. If you look at the formula, then the part you have to calculate first is nth derivative of f at 0, and then we will put that in this formula. So original function is just a 0th derivative. We didn't differentiate. So that is a natural log of 1 plus 5 of 5x. So 0th derivative at 0 is natural log of, this part is 0, so natural log of 1, which is 0. And then first derivative of f at x is, if we differentiate this one, then 1 over 1 plus 5x, but by chain rule, we have to multiply by 5. And so we will write 5 on the numerator. And then that is 5 times 1 plus 5x to the negative 1 power. And so first derivative of f at 0 is 5. Just this one vanish. We will keep doing this. Second derivative of f at x is what? Minus 1 times 5 times, if we apply the chain rule, then you will have to multiply 5 again. So 1 plus 5x to the negative 2 power. So second derivative at 0 is negative 5 squared, because 5 times 5. And the third derivative of f at x is negative 1 times this one, negative 2 times 5 times 5 times 5, 1 plus 5x to the negative 3 power. So this time, third derivative of f at x is 2 times negative will make positive, 5 cubed, 5 to the 5 cubed from here. This one will vanish. And then, so this one is 5 cubed. The fourth derivative of f at x is, this one was 2. So 2 times 5 cubed times 5 times this one, minus 3 times 1 plus 5x to the negative 4 power. And so this one from power, and this one from chain rule, and 2 came from here, 5 cubed came from here. And then that can be written as minus 2 times 3 times 5 to the 4 power. We combine these, and then 1 plus 5x to the negative 4 power. So fourth derivative of f at 0 is what? Negative 2 times 3 times 5 to the 4th power. And so that is negative 3 factorial times 5 to the 4th power. Nth derivative of f of x from here is negative 1 to the n minus 1 power, n minus 1 factorial, 5 to the n power, 1 plus 5x to the negative n power. So I just wrote the consequence for first. So here, this is a 3 factorial. This number is 4. And so this is 4 minus 1, right? 4 minus 1 factorial. And so when we generalize, when we think about nth derivative, that becomes n minus 1 factorial. And when this is an even number, the sign is negative. And so we have to raise to the n minus 1 power for here. Because when, for example, this is 2 n is 2, 2 minus 1 is 1 power. And so negative 1 to the 1 power is negative 1. Negative 4 power, if n is 4, then 4 minus 3 is cubed, negative 1 cubed. And so that is negative 1, right? And then fourth derivative, so 5 to the 4th power. So nth derivative n power. And then the same number. And so we wrote this one as a general formula. So nth derivative of f at 0 is negative 1 to the n minus 1 power, n minus 1 factorial. If you plug in 0 here, then this will be vanish. So 5 to the n power if n is greater than or equal to 1. So what we will use will be this one. So f of x equals summation n equals 0 to infinity nth derivative of f over at 0 over n factorial x to the n power. So that means that is n equals 0 to infinity. We will plug in this one there. Then that will be negative 1 to the n minus 1 power, n minus 1 factorial, 5 to the n power, over n factorial, x to the n power. But what you would notice here is when n equals 0, we cannot think about n minus 1 factorial because there is no negative 1 factorial, right? And so we will fix it like this, n equals 1 to infinity. So we have n equals 1 to infinity. We know that n minus 1 factorial over n factorial is so n minus 1 times n minus 2 and 2 times 1, and then n times n minus 1 times n minus 2 times 2 times 1. And so all the part will be 1. And so that is 1 over n. So negative 1 to the n minus 1 over n times x to the 5 to the n power, x to the n power. So summation n equals 1 to infinity, negative 1 to the n minus 1 over n. So 5x to the n power. So this is the final answer. So this is the Maclaurin series for the given function. And then we want to calculate the radius. We always use the ratio test when we think about the power series, Maclaurin series, Taylor series. An plus 1 over an can be written as n goes to infinity, absolute value of an plus 1 times 1 over an. And then that is limit n goes to infinity, an plus 1 will be negative 1 to the n power, 1 more power, over n plus 1. We just plug in n plus 1, 5x to the n plus 1. And then flip it. So n over negative 1 to the n minus 1 power 5x to the n power 1 over. So we think about the reciprocal. So we don't think about minus 1 to the n power because we are thinking about absolute value. And then we will just gather the same kind, and then these two will be together, n over n plus 1 times this one, and then 5x to the n plus 1 over 5x to the n power . So when n goes to infinity, this one goes to 1. So that is what? For this part, absolute value of what? 5x, right? Because this says 1 more power, n plus 1 minus n is 1. So that must be less than 1. So that implies x is less than 1 over 5 by multiplying by 1 over 5 on both sides. Therefore, r is 1 over 5. Any question? Third one is f of x equals a sine of pi x over 3. So zeroth derivative is a function itself. So f of x, that equals sine of pi x over 3. So we have to evaluate at 0. Then f of 0 equals sine of pi times 0 over 3, which is sine of 0 equals 0. And then the first derivative of f is pi over 3 times cosine of pi x over 3. So first derivative of f at 0 is pi over 3. Cosine of pi times 0 over 3 equals pi over 3 times cosine of 0 equals pi over 3. So second derivative of f is cosine's derivative is minus sine. So minus pi over 3 times pi over 3. Pi over 3, second pi over 3 is from the derivative of this one by chain rule. Sine of pi x over 3. So that is minus pi over 3 squared sine of pi x over 3. So second derivative of f at 0 equals minus pi over 3 squared times sine of pi times 0 over 3 equals minus pi over 3 squared times 0 equals 0. Third derivative of f is minus pi over 3 squared times this one is pi over 3 cosine of pi x over 3. So that is minus pi over 3 cubed cosine of pi x over 3. Third derivative of f at 0 is minus pi over 3 cubed cosine of pi times 0 over 3 equals minus pi over 3 cubed times 1, because this part equals 0. So that is minus pi over 3 cubed. So we will keep on going and going like that to get the pattern. So far what you can see is first one is a 0, and then pi over 3 and 0, negative pi over 3 cubed. And the first derivative of f at x is minus so we go back to here. So pi over 3 cubed pi over 3 times sine of pi x over 3. So minus, we have to put minus here again. So the entire thing will be positive. So pi over 3 to the 4th power sine of pi x over 3. 4th power at 0 equals pi over 3 to the 4th power sine of pi times 0 over 3. And this part equals 0. And so 0 times this one equals 0. Fifth power of x equals, we just apply the same method. So from here, we start from here, we have pi over 3 to the 4th power, and then chain rule is applied, and so we have to multiply by pi over 3. And then sine's derivative is cosine pi x over 3, right? So this time it becomes pi over 3 to the 5th power cosine of pi x over 3. And then 5th derivative at 0 is pi over 3 to the 5th power times cosine of pi times 0 over 3. And so this part equals 1, and pi over 3 to the 5th power. So here is a fundamental problem. So it starts with 0, f of 0 equals 0. And then first derivative became pi over 3, and second derivative becomes 0, and the third derivative became minus pi over 3 cubed, and fourth derivative became 0, and so on. And the fifth derivative is pi over 3 to the fifth power. So it is alternating pattern, 0 something, and so on. And then when we think about non-zero number, that becomes pi over 3, and then pi over 3 to the 3 cubed and fifth power. And so it goes up with odd degree power. And then other thing you can observe is this is plus, the next one is minus, and then it became plus. And so alternating pattern. If you think about the Maclaurin series formula, then it looks like f of x equals n equals 0 to infinity, nth derivative of f as 0 over n factorial x to the n power. So in this pattern, it's pretty hard to derive the general formula. So what we want to think about is, let me just draw the table. So what I want to do is I want to fill out this blank. So the first value is 0, the second value is pi over 3, and then it became 0. And it became alternating, so minus pi over 3, the odd degree 3, and then 0, minus, and then plus, and so pi over 3 to the increasing by the odd degree power, so pi over 3 to the fifth power. And then when we combine that with this formula, this part, so that's what I copied here. This one will be 0, and this is first derivative, and so it becomes pi over 3 x to the 1 power over 1 factorial and vanishes, and then this one becomes negative pi over 3 cubed x cubed over 3 factorial. The next one is pi over 3 to the 5th power, x to the 5th power over 5 factorial. So what I want to do is we just ignore all of the 0 part, and we want to just to think about k, and we want to manipulate the power. And so I want to record this one as the first index, and so 0, 1, 2, and so on. So power of x, these are odd number, and so we can describe that as 2k plus 1. That was n, right? So for this one, 2 times 0 plus 1 equals 1, and the next one is 2 times 1 plus 1 equals 3, and the next one is 2 times 2 plus 1 equals 5, and so on. The sign is the first one is positive, the next one is minus, the next one is positive, right? So f of x equals summation n equals 0 to infinity, nth derivative of f at 0 over n factorial x to the n power. And then we decided to use the sub-index k equals 0, k equals 0 to infinity, and then we can rewrite that as minus 1 to the k power times f to the 2k plus 1 power from here. That power, and 2k plus 1 derivative of f at 0 over 2k plus 1 factorial times x to the 2k plus 1. So summation k equals to 0 to infinity, and that is minus 1 to the k power, and this part formula is pi over 3 to the 2k plus 1 x to the 2k plus 1 over 2k plus 1 factorial. And so what I'm talking about is this part. So this is 1. If k equals 0, then it'll indicate this one, and k equals 1, then it'll be this one because cubed. So that is negative. That is consistent with this formula. And so what is going on is pretty confusing. Rather than something is the calculation is confusing, but indexing is a little bit confusing here. So this is the correct formula. But WebAssign may just ask you to put the sub-index n, but it doesn't really matter because kn are just unknown number. And so all you have to do is type n instead of k after you converted all those things. So if you don't like fraction over something form, then you will write n equals 0 to infinity, -1 to the n power. We will just separate this one. 2n plus 1 factorial times, you just write it down here like this. Pi over 3, 2n plus 1 times x to the 2n plus 1. So it's quite complicated. So what we want to use is this one. This one is an, right? We want to calculate the radius of convergence. Limit n goes to infinity, absolute value of an plus 1 over an equals limit n goes to infinity, absolute value of an plus 1 times 1 over an. Then it becomes limit n goes to infinity. So -1 to the n plus 1 over 2 times n plus 1 factorial times pi x over 3 to the 2 times n plus 1 plus 1. So what I did was just plugging in n plus 1 there, and then we will flip all those. And then we have 2n plus 1 factorial over -1 to the n power and 3 over pi x to the 2n plus 1. So those two don't have to be considered because we are thinking about absolute value. And we will gather the similar things together to simplify. This one is 2n plus 2 plus 1 will make 3 factorial. Here is the factorial. Here is another factorial. This is 2n plus 1 factorial. And then this one is pi x to the 2n plus 3. 2 plus 1 is 3 over 3 to the 2n plus 3 times 3 to the 2n plus 1 over pi x to the 2n plus 1. So let's calculate this part. So 2n plus 1 factorial over 2n plus 3 factorial. That goes like 2n plus 3 times 2n plus 2, 2n plus 1, and 2n 2 times 1. and 2n plus 1 times 2n and 2n minus 1, 2 times 1. And so this is 1. And so it will be 1 over 2n plus 3 times 2n plus 2. And then we will combine these two. So that'll be pi x to the 2n plus 3 over pi x to the 2n plus 1. And so pi x to the 2n plus 3 minus 2n minus 1, because those are in the denominator. And so pi x to the, those will cancel each other and squared. And we have these two, we calculate that, then 3 to the 2n plus 1 over 3 to the 2n plus 3. And this time something is flipped, right? 3 to the 2n plus 1 minus 2n minus 3. So instead of second power, we will have minus 2 power. So 3 to the minus 2 power. Okay. So we go back to here and we combine all things together, then we will get limit n goes to infinity pi x squared over, from this part, 2n plus 3 times 2n plus 2. And this one is 1 over 9, so times 9. And then this one is fixed, random number, but n increases, right? And so the entire thing will go to 0. So r goes to, so radius of convergence is infinity by the ratio test. Because no matter what x is, the limit will be 0, which is less than 1, right? Any question? This is quite complicated, and so if you see the lecture note, then there are some other problems, including Taylor series expansion and so on. But those will not be covered in this semester. And after the third exam, you will I will do the review for the exam. Each day I will cover the exam 1, 2, 3, 4 material. And those review will be very important because otherwise it is too broad. In the final exam problem, maybe somewhat, to a certain extent, those will be similar to the midterm exam, but the approach may be a little bit different. And so what I'm saying is the pattern of the problem may be a little bit different. So, and also it's important to go through all those things together. Otherwise, I think there are too many things we studied this semester. And so don't miss any lectures in the remaining semester because it can affect your final exam preparation, efficacy of final exam preparation. And yeah, and you have to go through the review for the exam 4, and because I sent out the announcement, and you will refer to it and follow through it. Any question about the exam or anything else? Okay, study hard and hopefully everybody will do well in the 4th exam and the final exam. And see you on Monday.